Good afternoon all and welcome back to another activity by Basra University for Oil and Gas SPE Student Chapter. I am Hussein Basil, the president of the chapter, Oil and Gas Engineering 4th stage student, and I will be the moderator for this session. This session is titled Artificial Intelligence from One Brain to Everyone Brain, and is the last session of the Digitalization in Oil Fields training. The session will be presented by a special speaker, Dr. Omar Alfarisi. Dr. Omar Alfarisi is an more than experienced engineer and advisor at Dragon Oil. I'll read some of his experience to you. He's an artificial intelligence senior technology advisor at Dragon Oil that holds a bachelor's degree in electronics and telecommunications from the University of Baghdad, master's in petroleum engineering, and a PhD in interdisciplinary artificial intelligence from MIT and Khalifa University. He has previous work and experience with Fortune 500 global companies, including SLB and Total Energies. He has innovated digital rock typing and invented the morphology decoder, for which he holds a patent. He also has received 6 innovation awards from the ADNOC BP Total Jotco subsidiary and the most likely to change the world award from the London Business School. Please, I would like to draw your attention to drop any question you want in the chat box, and the attendance registration form will be sent at the end of the session today in order to obtain course certificate. Course certificate of the training will be released after 1 week. Keep your mind with us and please listen carefully. Thank you all for attention and attendance to this session. And please, let's give a warm welcome to Dr. Omar for accepting this invitation and presenting this lecture. Please, Dr. Omar, the mic is yours and you can start.
Thank you very much, Hussein, for this nice introduction. And before that, thank you very much for the invitation. First of all, I'd like to say that I'm very happy and proud of the Basra University and its students and faculty, obviously, to support the SPE and such scientific events. So congratulations to you first on this great achievements. And I hope that I can add value to you with the talk of today. And please feel free to put all your questions so we can address them at the end of the session. I might ask you during the session if you wish to have it a little bit more interactive. So please feel free to answer as well. Of course, I'm asking here the Hussein, our moderator today, on whether people can open their mic if we ask a question during the event.
Yes, I enabled unmute themselves so they can ask directly.
Thank you, Ayun. And I'll try now to share the screen. Okay. Okay, you tell me when you see it.
It's clear.
Very good. Thank you very much again. So we'll make the topic of today what we call AI in oil and gas energy applications and advancements. The statement highlighted by Hussein, which is the previous talk we had in the GOTEC, which we call AI from one brain to everybody's brain. And here, I hope this can be an addition and a continuation for that. So here, we will go through an introduction to the artificial intelligence, and then we will go to some of the examples in the industry And from that, I hope you can gain some insight to take you further in your career in the oil industry. So first of all, this is the places where I studied, worked, taught, research, and some other societies and academic certificates. At the same time, these are some of the places where as well studied, worked, and published, where in 4 continents I studied and worked, and at the same time published in 5 continents. I received the award from 3 continents. So with this, going through the oil industry from, if you want to call it east to west, south, north. I'll start with a question, which is smart plus knowledge. So when we say smart, let's remember that everybody is smart. Human is smart, even animals are smart. If we take examples, they can build their houses, they can find life, and they can find water, and they can, and so on, and interact and learn. So everything's smart. But when it's smart, we add to it knowledge. What do you think would be the outcome? What we call that level, smart plus knowledge? Anybody would like to answer?
Well, I think you would call it an enlightened person, a person who's smart and has knowledge.
Okay, so maybe you can mention your name. Is it
Abdul Wahab, yes.
Okay. So thank you very much, Abdul Wahab, enlightened person. So yes. let's see what would be such a definition would be in our term here. So thank you very much, Abdul Wahab, and let's see. It is intelligent. So intelligent system is basically when a system is smart and you add to it knowledge or data, it becomes intelligent. And this is a differentiator for a human with the people who has the knowledge and the people who don't have the knowledge. So everybody's smart, but once you get the knowledge, on top of the smartness, you'll become intelligent, and that's a higher level. So smart system does suggest that it does not have knowledge, but it has already pre-built some smartness in it. But once you start feeding it with data, it becomes an intelligent system. And here we move on to the next level, which is artificial intelligence, which means that the system is smart by itself, has the capability to do some analysis, but now we are feeding it with data or knowledge. And that's where the artificial intelligence system is basically techniques that are trying to mimic the human behavior. And one part of it is machine learning. Other part can be robotics. So robotics is also mimicking human behavior, but might not have some learning. It might be a smart system. But if you have a robot with a smart system with the plus machine learning, that might become kind of a humanoid, something closer to a human than just a normal robot. And that's where you start adding things with the knowledge to it. So adding the data and the knowledge, that differentiate the systems from being smart and being intelligent. And that's why, as we said, machine learning is one of the subset of artificial intelligence. We said robotics is another subset. And one of the subsets of the machine learning. So machine learning is basically some of the, if you want to call it algebraic or statistical method to enable the machine to improve or solvers to improve the experience of that machine by learning from it. While the deep learning is one of those techniques. That is one of the mathematical techniques that are used to reach the machine learning. So that's basically, in short, on introduction on the machine learning and the artificial intelligence system. Of course, the talk will be focusing more and more a little bit on the machine learning itself for a reason. This is one of the main, if you want to say, added value today in the oil industry and in the other industries as well. Of course, adding other domains in the artificial intelligence like sensing, robotics, and so on, that will also add another dimension to it, but it will not be the focus of this talk. Now, let's keep in mind that machine learning is mainly divided to 4 different categories, if you want to say, and those are supervised machine learning, unsupervised machine learning, reinforcement learning, and what we call it hybrid. Now, when we say supervised, I like you to look at the images because the images represent what does it do. Unsupervised, supervised, basically, the human would have to have their input. So we have to have, if we have the data, we have the output. Basically, the human has to provide. I will use the laser to help you. Let me see if I can add the laser here. I think this is the laser. Okay. So the human has to provide an insight or an output to the data to enable the machine to learn from it. So by this, the machine is learning the human knowledge and able to learn from it. And in future, when we get new data, immediately it can predict for us. And that's super. In the case of supervised, look at the image here. We don't have, there is no input from the users, from the human, but we would use it to, but the machine would be able to provide clusters. So it will able to define, let's say in this case, 3 different clusters that are identified by the machine by itself in an unsupervised manner. Of course, there are algorithms for the supervised, and there are algorithms for the unsupervised. Reinforcement learning. Anybody can tell me what you think we would use reinforcement learning today for? And I have a car here.
Perhaps you'd use it for self-driving cars.
Self-driving cars, beautiful. Google Maps, Maps or Apple Maps, and so on. Absolutely. Reinforcement learning is basically enabling the machine to continuously learn from new data coming on top of what is existing on the previous knowledge. So it's a continuous feeding of data and improving the experience of that machine continuously. It's different than the supervised and unsupervised. In the supervised and unsupervised, we feed the data one time. We give it the data, it will learn, give you prediction, that's it, done. Supervised and unsupervised. And reinforcement learning, it will always tell you, it will always ask you that I'm learning. I reached this point. I want to reach now another point. Can you give me some more? Get more data. Now I learn. Now I can optimize my path. Now I can optimize myself. So it's continuously learning from the new data that is coming, adding it to the previous experiences. Now, hybrid is basically a combination of any of those 3. Can be supervised plus unsupervised, unsupervised plus reinforcement learning, reinforcement learning. So any combination of those 3 provide a hybrid. And an example of the hybrid is the generative AI. And one of the examples of generative AI is ChatGPT. And that's one of the areas that we're going to also show the strength of it today. Who's using ChatGPT? Everybody using ChatGPT?
I'm pretty sure everybody does, yes.
Wow, good. So we are already using artificial intelligence, and that's basically the future. So if we move next. So this is one of the agents of the ChatGPT called Ayla. So maybe everybody's using it today. So Ayla, we ask her a question. Give me, write a procedure to solve stuck pipe and high differential pressure formation. And it will give you, circulate the wellbore. So it will start giving you now information, start giving you guidance on how to do things. The same thing, if we ask even more in other domain in the oil industry. So we ask, write a procedure, solve limited number of slots in the offshore platform and to drill wells. So how you can write a procedure for such a thing? Again, it will provide you. Look at the current capacity of the offshore platform. Prioritize the drill the schedule. Consider alternative drilling methods like directional drilling, multi-well pads, and so on. So in this case, you could see that even a human cannot remember everything. Even the experts cannot remember everything. And not only remember everything, on top of that, not every human can know everything. There is no one single human can know everything. And that's where we said, but everybody's brain, my brain, your brains, all the participant brain, and all the whole world brain are provided to everyone. So we can use the brain of everybody when we are using ChatGPT. So everybody's brain in one place, and we are using it. And that's the power of ChatGPT. And that's where everybody starts understanding everything at the same time, or able to understand everything at the same time. Now we continue, of course, write a procedure to increase production from unconsolidated sand, for example. Again, it will provide additional information, characterize the sands, go further in the production, EOR, and so on. So all these are new knowledge that would be provided to the users. Another one, if there is a wax deposition, what we do, consider the temperature and the pressure, give you even more and more. And if you dig even more, you can get even more results. And you know it as you are using it, and so on. So you can improve all these questions and answer, and you can still get some results. So what is AI in this case? So how all this is happening? Let's give an example here. If, for example, we have an input data, let's say the differential pressure is bigger than 1,200 psi. And also, in that well, the depth is bigger than 2,000. In another case, the differential pressure is less than 1,000. So the difference between the upper case and the lower case is only one thing. The pressure here is less than 1,200. So if we look at now what would be the prediction, here we get stuck because the pressure is high, and here we don't get stuck because the pressure is now. This looks very easy to solve, and in this case, AI is not probably the right venue because very easy to. You have only two variables. One of them is changing, the other even not changing, and so on. So that any human can probably solve it easily. But when that algebraic or physical equation or governing equation become more complex and having more dimensions to it, and here we can see, for example, become 5 dimensions: differential pressure, depth, formation types, consolidation types, mud type. We have 5 dimensions into the problem, or 5 features. It is also in the AI domain, this is called features. So we have 5 different features to make a decision. What equation can put them all together? What physics can combine them together? Not easy to find by a human. So there are more complex physics than what we can easily. Well, we can try for the next 30 years, we can work on it until we find it, but that will not help us. We need an answer now. So what to do? And that's where the AI comes to help us by having the data provided for all these 5 different channels. Now the decision can be made from the historical experiences, from the data that we have, we can solve. And based on that, we can know whether there will be a stuck pipe or there will be no stuck pipe. So that's basically the AI. Now that's where, what is this one here? Enable close cooking. Okay. Shall I click this, Hussein, or is it disturbing? Do you see what I'm seeing here on the screen?
No, nothing is on the
Maybe
screen.
it's appearing only for me. Okay.
Yes.
Okay. Okay. Now, so here we can see that maybe I need to move this. Okay. Okay. Now, obviously, that also can be automated. And by adding that automation, we would basically enable the efficiency of the process to be happening continuously. Now, if we ask a question, when do we want to do the AI in this case? 3 months before the operation, 6 months before the operation, before planning for the budgeting, or no need to do anything? Anybody can answer?
I guess you'd have to use AI as soon as possible to avoid problems relating to computing power and data sets, and to collect as much data as possible for the AI.
Very good, very good. So basically, yes, we need it as fast as possible, and that would be in the preparation for any operation before it is happening. And that will be in the planning phase, and even before that. We can take now any other example, for example, in the reservoir. So if we have permeability here, only the water saturation, we have the same permeability, bigger than 400 millidarcy, but in one place we have the saturation 5%, another place saturation 30%. Again, what would be the decision? Here we target that zone in the top one because the saturation is low, while in the second one, it is not the one that we would target. But again, when things become more complex, what is the pressure, the thickness, the rock type? That will make a big difference now. And that's where the decisions start changing now. And again, that requires artificial intelligence from the previous experiences with such conditions. What was the production? And that's most probably one of the things that we're going to provide you, as we said during the GoTech for the competition, where we call it a contest, or people can work together in groups to identify what are the optimal algorithms to achieve the production targets. And again, you can automate even that. So let's look at what we call the opportunity value of AI. So here, if we look at our industry, we have from the geoscience, moving to the reservoir, the completion, going to drilling, production, network, and facility. And that's where surface and subsurface comes. And that's our value chain in the industry. Now, if we think of what would be AI, so as per Accenture, it says AI would provide 37% increase in the productivity due to AI in Sweden. And you can see the same rates for US, Japan, Australia, Austria, Germany, UK, France, and Spain. So there is a big impact on AI on the productivity for the coming years. And now, if we look at here, some of the opportunities, so if we take an example and we take such assumptions on the number of production, number of wells, and the amount of production, we can see the impact of AI if we increase our capabilities of our predictability here, then how AI can range from $50 to $80 million just in such assumptions, if we have just those amount of assumptions or production per year. And that's a huge. Obviously, it's getting smaller and smaller as you go to the end of the value chain for a reason, because you cannot be bigger than the ones that before that. But at the same time, if you add them all together, that become a huge number as well. So that's why targeting, understanding the early on in the subsurface part, so that will help you increase your production in future. So, however, we know that in the oil industry today, the implementation of AI, it is not one of the best, really one of the lowest. From among all the industry, we are kind of behind. And what would be some of these challenges? Why we are late here in the oil industry? And so this is something, you are the new generation, guys. You are the students of the future, and from Basra University, SPE students, you are the future. So you would think of it and see some of these challenges that we are facing today in the industry, which is what we call data characteristics. There are different types of data, and like we have exploration, we have production, and so on, geological, seismic, and so on. So the data itself, it's not easy sometimes to have those data even put in together. So these are one of the challenges. The second is what we call the legacy infrastructure. So each of these data sometimes and applications are already in silos and separate places. So even putting them together, even more complex. And of course, there are sometimes some regulation and some safety. Oh no, don't put that data. Oh, nobody can access that data. Oh no, this data is only for those guys. Those guys can see. So sometimes also make it even more complex when we put burden and constraints on top of that. And then, of course, stakeholders' concerns. Oh, that can affect my job if the AI going to do everything. Despite that AI going to help that job and make it even easier to be done. But that's also a cultural, if you want to call it, resistance. At the same time, there is acceptance and trust. Oh, what about the results? Is the result is really trustable? Can we accept or understand what is the outcome out of AI? Obviously, with the continuous knowledge about AI, people would be able to understand that knowledge. And we could see today how AI managed to help us just simply by using ChatGPT. Imagine you can do everything tomorrow just using ChatGPT, including your predictions. So, of course, the workforce skills, and that's what we were discussing about increasing and upscaling and training the people. And this one of the efforts, I think, as we said here today, Dragon Oil joining colleagues from Dragon Oil from the industry, joining the University of Basra students in this SPE event and training event kind of for both industry and academia at the same time. So this is one of the, and lots of our colleagues also in the industry and academia providing such courses and others to help, if you want to call it, increasing the skills on this regard. Of course, return of investment, how much is adding value the AI to me? Obviously, we can see when you can get an answer in 1 second, different than getting an answer after reading lots of papers and lots of books to come up, or even searching Google by itself is not easy when you get lots of possible options. So here today, the ROI can be easily justified really compared to before. But this is not all your industry. We can see that medical industry, they have the same thing. So they have similar things, they have different data and so on. So if this is a common problem, then we shouldn't worry because that's everybody's problem, and now we can solve it. Now, and that's what we call digital transformation leaders. And you are the transformation leaders. And here where, how we can take things, not just piloting it, but taking it beyond the piloting. The important part, obviously, that we, even in the pilot itself, we can learn some of these, building some of these processes, building some of these models, understanding some of the learning from those files. So we enable us now to go further to understand how it be the added value into going upscale. Of course, we need to move on then to the next phase, what we call the scale-up solution. And that will be taking us next to confront what we call the frontline changes. As we discussed, there will be lots of resistance, but at the same time, we need to take that. And you as digital transformation leader, now we are understanding, and you are attending these courses and attending these sessions and events. Now you are understanding the added value to the organization out of utilizing AI. And by this, you will be those transformation leaders. Of course, as we said, just asking one question to ChatGPT and you can get even more and can help you even more on how to do all these for you in more details. Let's keep in mind that as we discussed earlier, artificial intelligence would solve high dimensional complex challenges. High dimensional meaning, as we said, you remember when we said you have 5 features or 6 features or even more, 10. And in some cases, there are millions of features. It depends on how the complex the problem. And of course, once you use the artificial intelligence model, then you go to automate the knowledge to provide a high, what we call a high quality predictive and prevention and decision. As we said, when doing machine learning, you will need what we call topic domain expert, a person who knows about that topic, a person who is expert in that topic. That's very important. Of course, AI domain expert. And at the same time, we need for a specific area. Let's say we have an operation in Basra. And in Basra, we have a field there. The people who are working in that field, they have their own knowledge and experience in certain things. Their input will make the AI different than the input we just think using the data by itself to find out something. Because we might have, maybe we are missing some of the data or the knowledge that the machine can learn. And that's where you remember when you said smart plus knowledge, make it intelligent. We are missing some part of that knowledge inside the data or on the understanding of the data, we are missing in the intelligent part. Now, of course, that requires collaboration. And in this case, if we just take those 2 guys, that will be a general solution. But if we add to it the specific or reservoir, that will become a particular solution. And that's the solution that fits particularly for the case that we are working on in that particular field. Now, of course, we need universities to help in that. And in this case, for example, we have the University of Basra here attending today. Of course, technology providers, companies that are in the industry, and maybe you know them as well. There are several of them. Of course, any machine, any artificial intelligence requires data, and that's where the understanding of the knowledge in here, so the knowledge embedded there, and at the same time, we require some sophisticated hardware, which we call a GPU, or graphical processing unit, which is a parallel processing unit. At the same time, of course, that require what we call technology management, because some of the technologies will become obsolete after time, and that's where how things can be upgraded and improved with time, not staying as it is. And of course, that require having some AI platform and integration platform to put them all together. Of course, continuous review and upgrade is a must. Now, that's why taking such initiatives to make it a project, as we said, there is a resistance, there is answer. So how we are tackling this? So we'll take a very, very short here on how what we call a classical project management. In the classical project management, normally people initiate that project, they plan it, they execute it, the monitoring and review it in 5 steps, normally 5 stages. And one of the famous approaches was to manage that was using the Gantt chart, which was invented in the 20s in the last century, 100 years ago. Something like this. It would look something like this, where you have the time on the top and the task there and one follow. And that's very classic, which is not something that you would use today to solve what we are trying to make as a transformational digital transformation leaders. That's why what we call the agile project management. And agile project management is not a process, really. It has principles that we need to honor. As long as you're honoring these principles, you are managing the project. There is no really one defined process. And here what we call agile project management is an iterative incremental approach to managing projects. So it's continuous improvement and enhancement, where flexibility, collaboration, continuous improvement is a must. You achieve one step, you celebrate is not enough, because that's just the beginning. You do it again, you improve it, you enhancement, you celebrate. Still not enough, because you need more and more. And that's why with this approach, you can see that we had in the mobile phone, for example, we have 3G, 4G, 5G, 6G now moving and continuous, because those guys are using modern project management, going much faster than the traditional engineering, which is all other, because this this agile concept developed by software development or by the IT guys or by the if you want to call it computer engineers or electronic engineers. But the other type of engineering, they are yet now start using it as well. So that's why we promote having something that is a continuous enhancement rather than just a fixed model. One of the famous books, if you wish to read it, very good books, one of the early books, one of the early guys who wrote about it, and that you can of course use that book to help you here. So what are these agile principles? Satisfy the customer. If the customer is satisfied, that's it, you are done. Not only that, but you're welcoming changing requirements. If your customers keep on changing your requirements, no, I want this to, very good. So you are getting better because any change, you are better. Any change, you have a chance to, if you want to call it, to sell it better. If you chance to use it more, deliver working software frequently. So rather than waiting and building a software for a year or 2 or 3, every other week, maybe you deliver something with the team, with everybody seeing something delivered to them rather than waiting to the end. Continuous conversation. So these are the principles of Agile. You notice that there is no one specific process, but as long as you are able to achieve that, one of them is a continuous frequency meeting, one of these things. Of course, what we call business people, like the function, let's say the reservoir engineers, the engineering team, the production team, they sit with the developer continuously. So you sit always together as a team. And then what we call build the project among motivated individuals. The people who are not interested, no problem, they shouldn't be there. But the people who are interested need to be there because those are the people who are going to work on based on those trust between them and the support and helping each other to achieve that project. Now, of course, the success is that when you have a product that is working, if the product is working, you are successful. Also, you want to promote a continuous and sustainable development. So continuously enhancing, as we discussed, and of course, continuous improving the design. You want the experience of the customer and the user is easy product, easy, continuous enhancing it, make it easier for them. No coding maybe, just drag and drop and so on, until you satisfy those customers. Of course, simplicity as we discussed earlier. And what we call self-organized team. Self-organized, that means the team, they help each other. And if you want to call it, support each other to make the things working, each all together. And there is no difference. Despite there is a leader, despite there is a project manager, despite there is a developer, despite there is an end user, despite there is a technology enabler, despite, can be 5, 6 people on the team. But everybody is equally feeling that this project, it is their project. It is not the project that is of the project manager. It is not the project of the end user. It is not the project of the developer. It is not the project of, and believe me, after 30 years in the industry, I heard all these, oh, this is my project. They are the end user, that's their project. So the developer is not related to the project. Developers, sometimes they feel the same way. No, this is our project, we are developing it. Despite that, the end user also there. Project manager think, no, this is my project, I'm the project manager. Everybody, really, that's the classical way. That's 100 years ago approach. Today approach, anybody in the project is the project themselves. Everybody is part of the project. The success of one, the success of all. The success of all is the success of one. And that's the different approach that in agile development, and especially in the AI and software. Now, again, of course, becoming, of course, continuously more effective by tuning there and adjusting their behavior accordingly altogether. So here, just to have this subject stick in the mind, they call it the pig and the chicken. Just to give you an example, this is very known in the pig and chicken. If they want to make a partnership, the pig will become bacon, while the chicken can only put the egg. Do you tell me who's winning here? Anybody can tell me. If they are partnership, who's winning?
It's the chicken, of course. She's not there.
The chicken is winning because the pig has to cut from its flesh to honor this partnership. but the chicken is just making the egg, so it's not losing really a lot. And that's the traditional projects. But today projects really, so the pig is saying, no, I'm committed with my life, but the chicken is not committed with his life. But with Agile, everybody's committed with it. Everybody is a pig, basically. And that's the most important message. So if you want to work in AI systems, everybody has to feel they are a pig. They are part of and committed and part of that system. Not a project manager, not a developer, not just an end user, not just a monitoring or a guiding. No, everybody's part of it. Everybody is a pig. And that's why here what we call, they work together and helping each other into the progress. And team members also feel more committed when they participate to assign project or work during. So it is not like the project manager go to the developer, oh, do this, do that for me. Instead, no, let's think about it. We sit together. What do you think is the best for the project? Oh, the end user said, well, I think that's what I need. Okay, so the developer think, this is possible, but that's not easy. Or the project manager said, so, okay, so that will be a little bit, will elongate the time. So guys, is it okay for you, end user, that we're going to take another week? Yeah, it's fine for me as long as we're going to achieve this. Okay, developer, do you think that's doable? Yes, within 1 week. So such continuous support of each other is very important rather than do it, achieve it, make it. That doesn't work today. Okay. That will not help everybody, because if the developer felt it is not a pig, it will that developer will leave. If the end user feel that this product is not part of what she or he is looking for, then they will leave. Even they don't use the product after, and become just a lost time and lost money for the organization and for the scientific community. Okay. And I tell you, from 30 years experience, we've seen lots of such. Now, again, there are lots of meetings. Remember, when you go to the industry, hopefully in future, and the people whose industry colleagues here attending, there are lots of meetings. But those guys who are working in project, in some cases, they are exempted. And I'm giving you also examples today. And then in some of the departments working here and others, sometimes the manager tell you, okay, Omar, don't attend this meeting because I think it's better to focus on that. Yes, I fully agree. I support that. Okay, Hussein, don't attend in this meeting because you need to focus. Oh, okay, very good. So in this case, that will enable the people who are working on projects to be focusing on their work. Now we come to the machine learning. So this material made of mainly out of these three, two products, which is a book, very nice book, called Machine Learning with a Python, and there is lecture from MIT as well. So both combined to make this lecture here today. This is the book, one of the best books, if you wish, Introduction to Machine Learning with Python. But at the same time, we know we don't want you to learn Python now. That's not the purpose, but that's something that is good to get the knowledge out of it. But at the same time, we're going to do what we call no coding. So we don't want you to do code, but you can still do machine learning. So in terms of a definition of machine learning, it is, so this is the basically in a short term, it says it's just the ability of the machine to learn without programming it. So by itself, without writing a rule, it will learn. But the more official definition is this one really, which is basically is saying learn from an experience for some of the tasks, and to be able to measure the performance once is basically performance is the prediction. So learning from an experience during certain tasks and to be able to achieve the prediction. As an example, for example, the spam emails and so on, you get from it. Now, so why machine learning? Why not the traditional? Traditionally, we can write a code. For example, I say, if you see like credit card in the email or something, okay, this is a spam. But the problem, of course, with time, you start writing lots of rules. So that's how it was traditionally. You write a rule, You evaluate it, you analyze if there is a wrong, and you keep studying the problem and writing a rule. That's a human-based, rule-based, traditional. Of course, as we said, this is weak because unlikely you're going to capture the trends here. You are just trying to find every case without even looking to certain trends. And to look at trends may be even more hectic and so on. But the machine learning approach, basically enabling the machine by itself to start learning these trends. And that will make it much faster and much easier. So the approach today would be the machine through its learning. You give it the data, you give it the knowledge, the machine will learn from that, evaluate, analyze, and so on, and continuously by feeding that data to it. And that's basically the machine learning process. And as we said, the most important part, machine learning approach is flexible. So enable with more data, with more knowledge, able to be understanding and becoming more rules that are not a human can continuously maintain. So as long as you're continuously feeding the data, the machine learning is learning, evaluating, updating the data, and continuously learn. And that's the strength of a machine learner. You don't just build one model one time and that's it, you run it, you made, oh, I know if the temperature is this, if the pressure is that, if the saturation is this, there is good oil here. That doesn't work. One time it works, second time fail. We cannot live fail, succeed, fail, succeed. Today we have to continuously be successful. To be continuous, you have to have a continuous learning and having machine continuous learning and helping you in the decision. Of course, it is able to solve very, very large complex problem, we said, when you have lots of dimension. At the same time, it helps the human to learn. Because when you are learning, when the machine is learning, it's always giving you an insight. It's telling you, oh, that's what is happening. So you start understanding better the machine learning you train, then you study the problem, then, oh, put some data. Oh, that's what's happening. Oh, okay. So while the machine is learning, you are even understanding more. So always your knowledge is continuously increasing when the machine is faster providing you with an input. So let's look at this example. Very complex rock, micro CT. This is a rock. Look at the red areas. This is here. So this will be 3D also. This is 2D, but it is really a 3D. Imagine if I want to do these, if I want to discover all these areas here in the top, in the side, in the bottom. If I want to discover all these areas by myself, by hand, maybe I need 10 years to draw them. But the machine can do it in a few minutes. And that's basically how it is. So the 3D, you can see immediately start slicing it and providing me, if you look at the different areas, for example, here, this area, or that area here, which is we're highlighting, where you can see that the machine managed to get it. The same thing, look at the white spots here. All these white spots, these are high density, the micro CT, high density areas. And those high density areas, I just click one click, in few minutes, even less really, few seconds, I get the pyrite. This is pyrite, very high density rock. Now, so what is happening? In the machine learning, you have the data, as we said, and then there is something called structured and unstructured data. Structured data means tabulated. It's like Excel. And unstructured data, something like, let's say, PDF file or reports or images, or those called unstructured, or videos or sound and so on. These are unstructured. So now, to do the analysis, we need to train. We need to train the model. We need to train the algorithm to build the model. So that's why we split the data, sometimes 70-30, sometimes 60-20-20. We keep 120 at the end as a blind test to check whether we are done. So first we do the training, we train the model. Once we train the model and we get once we train the algorithm, we get the model. So once we get the model, then the model is basically, that is the knowledge that is captured by or the governing equations and the learning or the structure or the map of all the learning and the knowledge that the machine managed to learn. And now you can use that model for regression or a classification. Classification, that means, let's say, yellow, red, white, black, and so on, for example. Night, noon, this is classification. Regression is a continuous numbering, of course, like a number predicting numbers. Let's say the price of the stock market also, or the oil rate production also. So, and that's basically how we split the data, and this is for test. There is always, sometimes you can split it to 3, as we said, not only to 2. 1 for training, 1 to test it to make sure that your model is working okay. And the third set of data, you can use it as what we call validating. So basically, you keep it separate if you want to check it yourself without the team looking, so at least to ensure that you are in the right. So in a few seconds, you just label. You could see the red lines here. I just label this is as porosity, this is as fossil, this is as cementation, and so on. And every area I put it, immediately the machine within a few seconds managed to provide me with the answer. So now I know what is my porosity, and I calculate my porosity, where are my fossils, and where are my, the green one is my cementation. So now immediately I can know. And if you have voids, fractures, all you can identify. But now you could see I didn't write a code here. I just do it without coding. And that's why one of the software that I want to introduce to you that you can use immediately, you can go practice it and know from just after this course, you can immediately go and practice it, which is the Orange platform. Orange platform is very easy, no code. Immediately you have everything drag and drop. So, and you can go call it Orange software, machine learning software. You can just search it in the internet and you get it. Very simple. You can drag immediately the CSV file, you import it, and then you can immediately look at the data called data table. You could see it here from the map. I'm expanding one by one. Data table, you look at the data table, what is the inside, you can change it, you can modify it, you can now immediately then plot it as well. There is all these available for you to do. Once you plot it, you can now maybe look at transforming some of it, take some of the channels, all are available. No need to do any code here. You can do machine learning without coding. And then all these algorithms are here. You have the neural network, you have square, you have naive Bayes, you have SVM, random forest, any algorithm you wish to, linear regression, anything you like, you can utilize here. Then, of course, you can evaluate, as we said, to see how is your accuracy and something called confusion matrix, and your predictions accuracy also available. Unsupervised, you can do your clustering as well, and so on, also available, all the algorithms without writing. The most important things I want to highlight here is something called accuracy. Accuracy is basically what is called, what is the number of corrected predicted samples over the total number of samples. So that's your accuracy. That's the measure of how good the model is working. We'll touch base on some of the algorithms here. One of these algorithms is K nearest neighbor, whereas basically K mean the number of the nearest number. So if K is a 3, that means 3 dots near me. If I choose 2, I say check the nearest 2 things near me, and I want to be part of them or not. If other 2 are more near, I will be part of the other group. So the star here, for example, is near the red circles. And in this case, the nearest neighbor algorithm will consider this star as part of this group rather than. So this is one of the easy algorithms. It's measuring basically the distance. Euclidean distance is measured. And you know, this is the Euclidean distance. You can measure it very easy, which is basically the X or any dimension. It can be X, Y, Z, any other dimension. It can be 5, 6, 20, 100 dimension. But measuring the distances and then finding which one is the nearest distance, nearest vector, or the shortest vector, if you want to call, that would be your nearest. Of course, there is not only Euclidean, but there are others called Manhattan, which is basically used by Google, because Manhattan, you cannot take the shortest because there are streets. So that's called the Manhattan, for example, or city block algorithm, and that's another. And there are some other algorithm like Minsky and so on. So also you can study those, but that's just for you to know. Another concept is important is basically what is called the how to be underfitting or overfitting. So if this is the data, look at here. We are here underfitting. So just putting one line, let's say using linear regression won't work. Overfitting also, in this case, we basically using a 10 polynomial, 10 let's say x to power 10, such a polynomial also might be very complex to be used. But something maybe like this would be reasonable. Yeah, such maybe power function might be reasonable, or logarithmic function might be a little bit more reasonable. Here, maybe 2, 3 maximum, maybe to power 3 also. Now, that's what we call it the sweet spot. The sweet spot is basically look at the accuracy that we just introduced before and how much you want to fit. Of course, you'll be overfitting here and underfitting here. Meaning, when you learn during the training, which is the blue line, and when you are testing the data, and that's called the generalization curve, you want that point, at that point, basically, where you have now that, if you want to call it accuracy, where below that accuracy now, you are not able to generalize anymore. You start diverging. So once you start diverging between the generalization or the testing and the training, that's the point where you have to choose, because that provides you higher accuracy. You don't want to be here because that's very low accuracy. You don't want to be here despite high accuracy, but because when you give it a new data, it will give you any answer. So the best point is basically this point. And that's concept called sweet spot. Remember, this lecture is scratching only the concepts, but these are the concepts that you would want to dig further and understand more, of course, with your own time. And if you want to send me an email, call me at any time, you're most welcome. Whenever I can answer you, of course, I try to answer as much as I can. And the same thing here. So where is the sweet spot? Is basically that point here, where again, whenever you start divergence, that's the point that you want to stop once you see the divergence happening between the data and the test data. Again, so here the nearest neighbor, for example, and you can see basically if you choose sometimes the parameter k, as we say, k is the number of neighbors you want to check with. Here we are using 1 neighbor, here we're using 3 neighbors, here we're using 9 neighbors. So that's
okay. I found this on the web for if you choose, sometimes the parameter k, as we say, k is the number of neighbors you want to check with. Here we are using 1 neighbor.
Artificial intelligence
Check it
by
out.
itself start working. Okay. So now this is very important concept, but what is called the diversity of the training data is important. They said the best geologist is the one who can see the most rock. If you see more rock, you are the better geologist. And that's where Herbert Reed. Also, Stephen Covey said, strength lies in differences, not in similarities. The more divergence, the more differences there are. That's the better for everything we are dealing. Because everything will give you a new dimension. And with more dimension, more knowledge. With more knowledge, we said more intelligence. So, in general rules. So this is just a question. This is asking you, as an example. I don't want to go in detail. I don't want to take more of your time. But if person 1 see 10 types of this bird, 15 from that, 13 from this, 9 from the blue, 12 from the eagles, 14 from the falcon, and the person 2 sees 100 from here, 50 from here, 1 from here, 2 from here, 0 falcon. Which one you think is better, person 1 or person 2, based on the diversity?
Definitely person 1, based on diversity.
Very good. Thank you very much. Abdul Wahab, Sahih?
Yes.
Yeah, Abdul Wahab, very good. Because zero falcons. 0 falcons mean that has less diversity. Very good. So here, just look at some of the algorithm, famous algorithm, random forest, support vector machine. The accuracy is very high, those two very high. And the complexity here is medium. So when you have high accuracy and medium complexity, you are in a very good situation. And really, random forest is the only one. Random forest is the only one, the only algorithm that is high accuracy and less complexity. Less complexity means less time, less processing power. So random forest is one of the favorite. I have published a book and even patented some of concepts based on random forest. Okay, and look at the different even countries that invented it, mainly in the United States, and one of the early ones in the UK, United Kingdom. Lately, the XGBoost really is one of the good ones as well in China. And that's the other one, which is the extreme, the gradient boost, also is one of the good one in China. Okay, while LSTM also one of the good ones in Germany. Okay, so those are just to give you. Now, there is another algorithm called decision tree. It is basically when you ask a question, it says, for example, it's windy. So you start from windy and you have the outlook, sunny, and so on. Is it a true windy or not? So you start analyzing your data, and based on that, you said, is it windy? True. If it's true, then I have the 1, 2, 3, 4, 7 out of those data record. If I have false, well, now I can play. You see the play? You can go outside and play because it is under that condition. So decision tree is basically trying to look of what are the conditions that you can play. And that's where the algorithms start learning, oh, when it is windy and there is the outlook is sunny, or it is raining, or not, then I will play or not to play. So that's the decision tree based on that information. Remember, class is your output. So this is your knowledge. Class is output or knowledge, or this is your prediction. So using decision tree can also help you. Decision tree algorithm can also help you. By the way, random forest is a decision tree based concept. That's why it's very easy to be able to use it for classification. So I don't want to go through these details, but you can. Ensemble learning is one of the random forests. So random forest is basically an ensemble learning plus decision tree. Ensemble learning, meaning, can I change different places and different areas and different data sets and different everything I choose differently, so I can combine multiple different things. If you want to say different ensemble of, here they call it hypothesis, meaning that can I start from here or start from here, make the decision tree from here, choose some part from here, and so on. So all these type of ensemble learning to enable you. The idea of ensemble learning is, if I learn it only one way, I may miss learning it the other way. Can I run in parallel, starting from Outlook, starting from the other channel and do the decision tree differently? Because the decision tree here can be only two levels. But if I start from here, I can have 8 levels. But if I do 2, I know that I can reach an answer without going through a very lengthy process, and that's called ensembling. So the ensemble learning basically is enabling, which says different learning algorithms, and also different data sets or subsets and features and parameters can be selected once I can reach the answer with different trials and errors, rather than going only in one direction. And that's called ensemble learning. And as we said, bagging and boosting is part of it. How I can go in parallel and test, rather go in series. Now, and that's why one of the ensemble decision tree is random forest, and that's one of the best solutions. Now, neural network. Neural network is again a concept of basically kind of providing a polynomial that is able to answer all the whatever the problem. If the most complex problem can be solved with deep neural network. The most complex, any problem can be solved. There is nothing cannot be predicted today with neural network, provided that the data is represented, of course. If the data is not presented, if the data is not trained, we cannot predict. And that's a very important assumption, because if we train it on something today and tomorrow, what the data does not represent what we trained with, it will be a wrong prediction. So we have to make sure it is the right representation. That's why, for example, weather prediction cannot be maybe made exactly after let's say 1 week or 10 days, for a reason. After 10 days, you might have something developed like, let's say, an earthquake, which was not part of the learning. If it's not part of learning, the machine cannot predict, oh, because of the earthquake, there was wind, because of the wind, they changed the temperature and so on in other areas in the world. So that's why neural network is perfect fitting, but if the data is correct. Okay, that's very important. So what is the idea of the neural network? It's basically saying I have x1, x2, x3, dimension 1, dimension 2. Remember, 5 dimensions: saturation, pressure, temperature, whatever. All these are dimensions. You put these input, you make a sigma, each one multiplied by a weight. This is the equation. And that's the equation. Temperature multiplied by weight 1, pressure multiplied by weight 2. But how to find those? From the data. So keep on analyzing the data until we find it. Now, this is what is called activation function, where it's basically when the summation reaches a certain point above certain threshold, it will trigger yes, no, yes, no, yes. Okay, so no need to dwell there, no need to look at. I'll explain it even in some more detail here below. Okay, so as we said, so let me give you an example to make it easy for you to comprehend it. Here, as we said, let's say the first one was temperature, the second was the pressure, the third one was saturation. Multiply by a weight, put it in a function. But remember, somebody will say, yeah, but the pressure is different unit than temperature. Temperature is different unit than the saturation. How we can put 3 different things in one? So there is a stage before putting the data in any neural network or even machine learning, something called normalization. All the data has to be normalized to be represented. So, and normalization is basically the value minus the minimum over the minimum plus maximum. That's basically normalization. Okay, so all the data will be normalized before going inside, and this is very important stage in machine learning. So the data is normalized: pressure, temperature, normalized pressure, normalized temperature, normalized saturation, multiplied by the weight, getting the function. So how does it work? Basically, let's say this is the weight. The answer was 21.34. That's basically how the function works. So let's say the output was permeability. So the permeability in this case is 21. Now, so how such a thing? So and sometimes can be classes, and that's where you need the function, the activation function, tell you whether yes, it's a class 1 or a class 2 or not. So how this would work? Just let's look at it. Initially, we put the input data, and then we initialize the weights, and let's say this is the output like this. Now, but if the output is 0.8 and it should be 0, so then something wrong. So I have to change now the weight. I break those. So any arrow is basically a weight, the multiplier by the data. I change the weight and I correct it until I learn. I change the weight and I improve the weight and correct the weight until I keep on learning. Once I improve that, continuously now I start learning what is the optimum equation that can honor, or the governing equation, or the physics of combining those all together to make the answer. So, and that's where what we call, that's initially how it was. Finally, it will become a different answer because we keep on learning and so on. And look at it here again, and how with continuous learning, the boundaries are changing and keep on changing that polynomial until that polynomial can fit and enable to fit the deep neural network. And why we call it deep? It is deep learning. Call it deep learning, meaning not only one layer, but continuously, layer after layer of learning, one time after the other, one time after the other. And that's where we said, the more intelligent the system is, the deeper the learning, the more the knowledge, the more you feed it, the more you teach it, the more, not feeding just with data, but you have to feed it with your insights, with your knowledge, with domain knowledge, with expertise. That's the more the knowledge it gains, the more diversity of the data, the more ability to get from the different aspects. And that's where it reaches. There is a level, what we call it artificial general intelligence, where the ability to understand all the knowledge and providing you with the best answer. The more integration of data, provided that you have a control on understanding what that. Okay, and that's basically the neural network as we saw. Now, so it's very simple. It's basically solving a polynomial. Now, SVM, notice here SVM. So SVM do something else. You see here, it is the same data. SVM perform a transformation. SVM is developed by one of the Russian mathematicians in the 80s and 80s or 70s. Very nice model, which is basically transforming the data rather than doing all these polynomial equations. It takes the yellow and transform it to another domain. It says this is in another domain, and take the blue and put it in another domain. Separate them completely, and finding the relationship for those, and now having a new transformation. There is an algebra and a transformation methods. You can study that. So SVM is one of these concepts. Okay. Basically creating a new domain. So rather than using it, let's say, in a Cartesian domain, it will convert it to a spherical domain. Rather than a spherical domain, convert it to, let's say, a pyramidal domain. So it will change the way the representation of the data by changing the domain or the dimensions of that data. So let's look at some of the application of the machine learning here in the oil industry. So simply, you are in the oil industry and predictive maintenance, reservoir characterization, seismic interpretation, production optimization, drilling optimization, well log analysis, asset integrity management, environmental impact assessment, equipment, geomechanics, supply chain, energy optimization, you name it. If you are interested in AI, and if you're interested in any of these areas, we can find for you an answer. You can find an answer. You can search it. We all can find a solution for anything we are looking. Let's look at some, go deeper. We dig deeper and see some, let's say, just for predictive maintenance. The first point, you remember the first point in the top? What is it? Predictive maintenance. Do you think just like this? No, just go dig deeper. So how you can help me in predictive maintenance? Rotating equipment. Rotating machinery have vibration, has that. So there are lots of changes happening. Pipeline integrity, you have corrosion, you have. So there are lots of things can be basically turbines, storage tanks, everything, safety systems, everything can be. And what are the algorithms that are used? We see random forest, support vector machine, which is SVM, the one we said transforming the dimensions, a neural network, and all the others, you can see them repeating the same. Those are the ones that we just studied. Those are the ones that are used to do all these work. So what we can do, prediction of the failure of the pumps, detecting leaks and corrosions, identify faults and transform generator motors. And there are lots of things we can do today. We can launch lots of AI projects today. Which one is the one that we want to tackle? Okay, and that would be of course, the company, the teams, needs, and so on. So this is just for predictive maintenance. Imagine. Now, not only that, we can, of course, we cannot run just using an algorithm. What we need, of course, we need data. So now you have the algorithm, random forest, but what you need for the first one, you need vibration data, temperature, pressure, rotational speed. What do you need for other? So now you can also capture the data that is needed for that. So you can also use ChatGPT even to help you in understanding or missing some of the data if you were missing that we can provide it. Let's go to machine learning for reservoir characterization. What we can do, and let's see what's been done already also there. Seismic interpretation, well analysis, reverse simulation, analysis, and those of the high impact. Okay, those are the high impact areas. So all those using those machine learning algorithm, which is random forest, Gaussian, and so on, decision tree, neural network, to make that learning happening. And the input data is here. Those are your input data. Okay, so that's when it comes to reservoir characterization. If you are interested in reservoir characterization, you can find a lot of application for AI, and you can work on that, and you go into more details on it. Drilling optimization, the same. Drilling rate optimization, drilling field optimization, bit wearing, direction drilling optimization. All those are of a high impact as well. Okay, so all those are available.
بس مو مبالغة عالية.
Sorry, I'm hearing somebody speaking.
بالشهر 300.
Hello?
Sorry for that. You can continue.
Okay.
yeah.
The same thing for production. So again, AI for production, reservoir modeling, well performance analysis, production forecasting, artificial lift, flow assurance, production, all those are of a high impact. All of them of a high impact, and you can, and even the names of the vendors who are working on them and the projects that they are working on them, we know them, and with their input data and so on. So all these are available for us today to embark on. Now, another concept I just want you to highlight because it's important, which is optimization algorithm, which is not artificial, which is not machine learning, it is optimization. So there is a difference because sometimes people talk optimization and machine learning, but however, machine learning can be used to do a continuous optimization by using machine learning, but not the optimization itself, but optimization can use the machine learning as well. So let's differentiate. Optimization is basically, if you look at this, if you have, where are the optimum area? If you keep on doing different circles, or where is the optimum place? Basically, the optimum place, obviously, when everybody's converging to, and this is your, let's say, the yellow spot there is your optimum area. Okay. Now, if you, it's called the global maximum or global minimals. So just to touch base on the organization, on the optimization algorithm, just look at here. So if you have more than one constraint, constraint 1, constraint 2, constraint 3, and so on, basically around the edges are your optimum points. So there is an optimum point here, and there is an optimum point here, and those are the places. Graphically, you can solve it when you put all your constraints, you know where are the optimum point. Now, obviously, that's what we call the objective single numeric quantity or an objective function to what we call the global maximum or global minimum. Of course, we need, so part of the optimization, you identify the objectives. You have also the variables, which is basically the quantities that can be manipulated to optimize the objective. So basically moving around the edges to reach these points, let's say 5, 5, and 6 point. So those are your variables. In this case, for example, x1, x2. And of course, putting your constraint. Your constraints are those curves. So those are the curves that are constrained you. So you have the objective where basically the maximum or minimum, you have the x1, x2, and you have your constraint. Now you need to optimize. So in such cases, of course, there is a procedure on how to do it and how to solve it. And basically, graphically, you could solve it here. And that's, you can take it step by step. You can study it, and you can go through how to do it. Now, let's take it one step further even. And we ask this question: is optimization algorithm is a machine learning algorithm? What do you think the answer? Yes or no? Is it yes or no?
Well, it can be, but it doesn't have to be. It's not necessary, but it can be.
Can be part of it. So both can use each other, but they are different. So let's see the difference. The obviously used for solving optimization problem, and here used for pattern recognition and prediction. So see the difference between the utilization. Now machine learning can do some learning from the optimization to even optimize better, and that can be done at the same time. Okay, the AI capability. Optimization algorithm has no AI. There is no learning. It does not learn. Okay, machine learning does learn. So machine learning can learn from the optimization algorithm to make it even better. And that's the most important difference. Okay, of course, you can see the different applications and so on in details and so on. And this is, of course, look at the different optimization algorithm, like gradient boost is one of the best algorithms in here, Newton method and so on. Now, go to ChatGPT and write this. Python code, perform optimization to find a global maxima using 2 best optimization algorithms. Then produce a table that compare the 2 algorithm accuracy. In 3 seconds, I got a code, run the code, and I got which one is better. And here it's providing you with the different tool and the results. Immediately get the results out of it. So here we can see that with machine learning today, you can write a code, you can develop it, you can do optimization. If you are willing, you can put the data, even if you don't want to go with codeless Orange that I showed you or any other codeless. Orange, by the way, is free, so no need to pay money, so you can use it immediately. You can use ChatGPT to do. Put the data, ChatGPT predict, give you the predict. This is the last thing, talking about some of the applications again in the reservoir characterization, monitoring the rock basically. So from this analysis that we showed before, taking those and analyzing the porosity and the lithology. So from here immediately, of course, we showed you how to label it, very easy. Got the porosity now, we have the porosity, just calculate what is the red area there. We calculate the red area, automatically the machine can do it, immediately we can get the porosity. The same thing as we discussed for the lithology, what is the volume of the pyrite? We immediately can calculate minus that, minus porosity, give you the volume of the limestone. The same thing for the saturation. This is the MRI. From the MRI, we calibrated it using the crude oil. So from the crude oil, we managed to calibrate that. By the machine learning, we are able now to convert the MRI, which is looking for fluid, different than micro-CT. Micro-CT look for the solid, MRI look for the fluid. So here, immediately, we can spot where are the area that we have more fluid, which is basically the green, where that's your oil, and the remaining is basically, if you want to call it, the less fluid. Seismic, again, you can use it. It's a published work, 2018, on how you immediately can separate the different areas using machine learning. Very simple. Today, we are using also relative variability to get it from the images and calculating even more properties and so on. So that was basically a brief. I hope that was helpful to you and looking for your Q&A. And thank you very much again for this invitation. And hopefully that was a good lecture. Thank you.
Thank you so much, Dr. Omar. I think that was a very interesting and informative session that we all was happy to attend. Please all, you can ask any question you want by just directly unmute yourself and ask.
So I see in the chat box there are also.
Yeah, I saw a question. Can you suggest some websites, AI websites we can use? I think you suggested Orange.
Right.
Yeah.
Orange is one of the free softwares that you can download immediately and put it and install it in your laptop. So no need for any other thing. No need for any coding, no need for anything. Just download it. And it has lots of videos, YouTube videos. So immediately you go and see all the videos and it will teach you step by step. So if you spend 2-3 days, I'm sure you're going to be an expert within a week. So immediately you can start working on machine learning. Okay.
All right. So may I ask a question?
Please.
Is there any ideas of SaaS applications like software as a service in petroleum industry? Like just as ChatGPT serves a wide base of audience. So in petroleum industry, can we use an application that will be applied to many customers without any modification, just as uploading it to a website and it will work for everybody?
Thank you. Thank you very much, Hussein, for the question. Really here, if you remember in the lecture, we were talking about what we call the generalizing, general and particular solution. You remember that, yeah? So in the general solution, normally, ChatGPT, for example, you can use ChatGPT also for prediction today. Upload your table, tell it predict for me the Y, put all the X, 1, 2, 3, put the table, send it, put it in the chat, ask it to predict for you the Y, it will predict. Of course, ChatGPT is online, and this data will go, and this is so that's why that's the people cannot use it as it is, if you want to call it. That's why we have to have what we call more secure type of. So we have to secure our data. We don't want our data to be seen by everybody, especially companies that want to protect their data and so on. That's what technologies, operating companies, oil companies, even governments, and so on. So that's why most of the time what we do, we need to bring in that ChatGPT engine. For example, we're having a project now that bringing ChatGPT in and learn from our data as a particular solution. In addition, we can have all the learning of the existing knowledge also inside and embedded in it. So basically, it will learn from our data and can also predict from our data at the same time. So that engine, yes, can be provided. Now, can we use it as a SaaS? Yes, we can use it as a SaaS, which is online. So using, let's say, Azure, use AWS, use Google, you can use them. But the only constraint here we have is that the data should not be put in that one. Our data we cannot put. That's why we are limited on not putting the data. And that's why we have to bring in, most of the time, most of the oil companies, they bring in those engines and all these services in a premise. So if you want to call it in-premise SaaS or cloud, so we put the cloud inside our company, let's say, and we can use it there. So that's how does it look like. I hope I have answered you.
Very good, very good. Thanks.
Yes.
Abdul Wahab has a question. Please
Yes.
ask your question.
Yes. So if a system is complex, then we increase the computing power and time needed to get an answer or solution, which
Right.
is really the main constraint. But suppose we have like a lot of computing power and a lot of time. Do we go with extra complex systems, or is there like a threshold that if we exceed it, then by overcomplicating the problem, we break it? Or is overcomplication is you get the idea.
Yeah. No, very clear. Very good question, by the way, also. Thank you very much. Really, this is very, very nice, what they call a dilemma. You increase the computation power, and now you want to solve it faster at the same time. Now, in the middle, there is data, algorithm, yeah, and hardware, machine, algorithm, data. You can increase the amount of data using better algorithm or faster algorithm, let's say random forest, and more higher power machine, so to solve. Now, if you want to solve even more and more, the more you want to solve, there is always a time constraint, because you need to continuously improve your algorithm. You need to continuously increase your. Now, if you don't want to increase the power of the computing, let's say you are constrained, you don't want to spend money on that, then you have to, but you still need to have more data, then you have to improve your algorithm. So you could see that where you can optimize. That's why there are other ways of doing it, what they call it pruning, which we discussed today, pruning and boosting and so on, where you cut some of the data. So if you know that lots of data is similar, so for example, in the image before, if I go here, in this image for this one, so this is one of the concepts we use to make it faster. What we said, anything black is poor. So no need for me now to analyze every pore. And that's the difference between, for example, simulation-based analysis and machine learning-based analysis. In simulation, we have to run every equation at every point. And that's why simulating a rock to find an answer, let's say, to get a permeability or antipermeability or wettability of PC or any property by simulating that one, may take you a year maybe for such a rock. But machine learning takes a few minutes because it's not using the whole data. It's just using the one thing called black. And the black contain the value of porosity equals 0. And it does not going to calculate the porosity equals 0. That's it. It's first do the analysis by defining in the classes and then put just multiply it by the amount. So it's become much faster. That's why improving using machine learning by improving the way that we're looking or analyzing the problem by using the algorithm that is more suitable, like the SVM, for example, which is basically changing the dimension and solving it much faster from doing neural network. So improving the algorithm, if you want to maintain the power, we have to improve the algorithm or change the amount of data. So rather than I put, for example, if you look at here, all of them gray, the same color. Do I need to define and do a simulation, an equation, and run calculation for every point? No need. I just highlight them like the slide, like the picture before. We just highlight them and that's it, like this, for example. We just highlight that area and now we know this is 5 porosity, this is 10, this is 20, this is whatever. That's it. So now you could see how machine learning now in solving some of the areas that sometimes we need to change the amount of the data we use, what data we can input and what labels. Imagine if I keep on labeling and putting more detail of the detail. Yes, I can get maybe a better answer, but can give me very little of an accuracy that is of no impact. And that's where how we're going to decide what is the most important parameter for us. Time, accuracy, quality, impact, and so on. And that would be your decision. Okay. I hope that was an answer for you, Ayoni Abdulwahab.
Yes, it was an eloquent one. Thank you.
Yeah, thank you. Barakallah.
Can you elaborate on using reinforcement learning in reservoir simulation or any other areas of oil industry?
Yeah, thank you very much for this. So, for example, one of the uses today of reinforcement learning. So let's understand first maybe what is reinforcement learning, so everybody will be on the same page. So reinforcement learning is basically what we are saying. Imagine it is like a decision tree. Imagine it as a decision tree. What I'm saying, if I choose, let's say, this area will give me +1. If I choose this area, it will give me 0. It will not add to me something. So I will avoid this area. Not adding for me extra production, let's say. So I will avoid this area. So I go here. If the next phase, the next step, what I do, I said, okay, so let me move to another. I go here, oh, this is 0. But if I go here, no, this is 1, adding something to me, add oil to me, add more oil to me. So let's take it this way. So the reinforcement learning start understanding, if you want to call it, the delineation or where are the boundaries of what are my best areas or not good areas or whatever. So by this, I can learn how things and the boundaries can be happening for example, for the production. We are using it today also for designing the well trajectory in the reinforcement learning. So what we are saying, drill here. Can we drill here more? No, but I will have a problem because if I drill here, my pressure is higher. So I need an area which is less pressure. It will change the direction. Oh, here is the pressure is bearable. So it will change the direction. No, move here. No, there is consolidated sand here. If I go there, it is less consolidation. Okay, so the path will come like this. So you see now how? So that's with continuous learning. Next time, the machine also will be able immediately to draw this path. No need for it to do the same practice again. Now it's learned that path, and now just going to add for me some additional dimension to it. So that's 2 examples I just gave you for the reinforcement learning. One project, we are launching it with Khalifa University soon. In this regard for the reservoir using simulation and so on. And the second one is also launching it for the drilling team as well. Just going to start soon as well. I hope that was up to you.
Thanks. That was very clear.
Awesome.
Thanks for everything, and thanks for the accepting the invitation. And I hope to see you in another activity by Basra University for Oil and Gas. SPE student chapter. We hope to participate in the upcoming contest.
Most welcome.
Yeah.
And
Thank you
we'll send
very
of
much.
course, the invitation, and we hope that you will be able to join us at GoTech. We'll send you also the AI context and the contest that we're going to announce soon. So hopefully we'll see you again also on GoTech and the rest of the team. And thank you again for Basra University and the SPE chapter and all the great efforts. And of course, the Dragon Oil team and the HR team, Dragon Oil, to facilitate as well within Dragon, the team, and to attend this event as well. Thank you very much, Hussein, for you, particularly for all the great efforts and great organizing this event. Thank you again.
You're most welcome. Thank you. And goodbye.
Bye. Bye.